All right. Can I have a pen, please, for a sec? I need Which word is confusing everybody in chemistry? Transmit, is it? Where is it? Difference between?
Y and T, and reflection.
Are we talking about metals?
No, reflection and transmission when you absorb light.
The absorption and yes, this stuff. So you have when they reflect or when they absorb, isn't it?
I didn't get this question.
So what is the question? What is the difference between
Reflection and transmission.
Okay, so the reflection is that the light comes in and bounces off the surface.
Yes.
Whereas with transmission, the light is made at the surface.
I have lost.
So we don't know if that's exactly right, or what they want. So, for example, okay, if I have something, like here in the board, sunlight is being reflected off the board. You can see it's kind of shining. So this is reflection. Transmission, the light is being made at the source. So the difference between reflection and transmission is, in reflection, the light is being bounced, I suppose. I don't know if that's the...
Reflected by the surface.
Yeah, but we should explain reflection with the word reflection. So you could say something like this. Now, if this is wrong, I'm not responsible. So, in reflection, the light already exists and is only redirected.
Reflection of the light? Okay.
Transmission, 2 S's? One S only. Is that right?
T.
There's a T? Transmission. Is it transmission?
Yeah.
Yeah. In transmission, the light is created at the source from another non-light form of energy. So we can think about it like a light bulb. See, that's what I thought. Are you sure, KJ? Okay. So in transmission, maybe something like this. The electrical goes in, and then the light comes out. So the picture also helps in your definition, okay? Are you happy with these definitions?
Yeah.
Do you understand them? Yeah? KJ, did you have this definition already?
Yeah.
What did you write?
Basically like the same thing.
Well, probably different verbs. What did you say exactly?
Transmission, the light is absorbed and emitted. like imitate through rays. Like this is not clear because light bounces over it.
Yeah.
That's clear because it goes through it.
Okay, actually maybe, I think you should delete this word. Actually, I'm not convinced that it has to be non-light to begin with. So just delete that word. Because you just reminded me there that maybe, yeah, I'm not so sure. Anyway, you'll find out after this class if it was right or not.
I'll give it to Lorraine.
What?
I'll give it to Lorraine, that's it.
See what happens, I don't know.
He will check that all on homework, so you see everybody has the same definition.
I'm not sure if transmission means that the light does it have to be absorbed to begin with and released?
Yeah.
I don't know. So the question then, KJ, is I'm not sure if the word non-light has to be here.
Something, the energy absorbed,
Yeah.
and the rest energy lost, it transmits into some color.
Yeah.
Yeah, it's like it absorbs the spectrum of light and changes it, transmitting another wavelength.
Some complex science.
Whatever, close enough. Okay, collisions now.
I'll roll it in the home because
Okay, you got the title?
No.
Transmission. Yeah. Okay, can I go on? Yep. Okay, so just to help you understand the word collisions, there's a picture for you, snooker table. This is a special type of collision in physics. It's between two masses and there's no external force. So look, I just want you to know collisions in physics means one mass hits another mass. That's what we mean by collisions in physics, just like that. Right, so our idea for collisions is something called conservation of momentum. Now just before we go on, what is momentum? What's the formula for momentum? Do you remember? mv. That's momentum. Okay, so when a collision happens, the momentum will be conserved. What that means is, I like the energy. Do you remember the conservation of energy? So the conservation of energy says the energy at the start equals the energy at the end. Yep. You have the same idea with momentum. The momentum at the start equals the momentum at the end. You don't lose momentum. Just like you don't lose energy. It stays the same.
You write this?
Well, you should, and also the formula. What? You got what? Of course. Collision. True, but I never really liked this example because it only works when the engines are turned off, which is not realistic. There has to be no external force.
When they test the cars, they don't start them until they put something under the car and
Oh really?
Yeah.
The engines are not running? Are you sure? Oh, okay. It's like on some kind of conveyor belt or something.
Yeah.
Oh, right. Well then in that case, yeah, it'd be like that.
check with the wall.
Yes. Okay, so, yeah, I'm going to explain now. So what you have is, this is mass 1, M1, and this is M2, yeah. So this is coming along U1, and this is U2. And then they crash, and then it's V1 and V2. The speeds.
Until they bounce back, right?
Yeah, well sometimes they can bounce back, and then sometimes they can crash, and then move off together. So, if you want, the M1 is the mass of the first object, M2 is the mass of the second object, U1 is the initial velocity of the first object, U2 is the initial velocity of the second object, V1 is the final velocity of the first object, and V2 is the final velocity of the second object. If you need to write any of those down, please do. So I have U1, U2, then they crash, and then it's V1, V2 after they crash. Twitter?
We can. No.
What's up? Facebook?
No.
What you looking up?
CUOH2.
C.
No, this one.
Oh.
I write up.
Okay. So let me just give you a warning here, please. This only works when the system is closed. What I mean is there's no outside force. For example, we can use this formula when this happens, but we can't use this formula if this happens.
Because of acceleration.
Yeah, because of the gravity. So we can only use the formula when it's like this. We cannot use the formula when it's like this because of the gravity.
But what if on the moon, can you use the formula like this?
Say again?
On the moon.
We still couldn't. Although it would just be less inaccurate, we still couldn't. Yeah. But we could in space, when there's no gravity. But the idea is, we usually use this formula horizontally, not vertically. Okay. And there are two types of collisions. Our first type is elastic. This means that no kinetic energy is lost. And inelastic, which means some kinetic energy is lost. You need this vocabulary for the exam. Please make sure you know these words. So if some kinetic energy is lost, we say it's inelastic, and if no kinetic energy is lost, then we say it's elastic.
This one, nothing is connected to us, right?
Correct. Which, by the way, never really happens. We never really see problems like this. All our collisions are inelastic, really. Yep, you got this? The two definitions, Fahad? Did you write these down? Write them down, Fahad. I said it's important for the exam, this vocabulary. Will you really? I can check your Moodle activity? Well, write it down now anyway, it'll make me feel better. I'll be able to rest easily tonight.
This is a fix.
Okay, well I need to probably go on now. You have this? Can I go on?
Yeah.
Yeah? Okay. So I think we probably have an example to look at now.
No?
Yeah. what I want you to do, I just want you to draw this. I want you to practice to draw it. So what you have is a 1 kilogram trolley is moving towards a 2 kilogram trolley. You know what I mean by trolley?
Yeah.
Trolley is, that's one trolley. Trolley is like a little toy car. Like a small toy car. That's a trolley. Hang on.
In the modern day.
And that's another trolley, but that's not the trolley I'm talking about. Like a little toy car. That's what I mean by a trolley. And another meaning, yes, you're right, like in Tesco, this is a trolley too, where you put your...
You're talking about a car.
Well, in physics, it's going to be this more likely than this, okay?
So it's called trolley.
Trolley, yeah. Trolley, I have one in the office. It's a small little toy car. Well, I call it a toy car so you can understand. It's just like a small little car. The key is there's no engine. It's just a small little car with wheels on it. That's all. Okay? So you have 1 kilogram and a 2 kilogram. And the 1 kilogram is moving, but the 2 kilogram is not moving. Okay? And when they collide, they stick together. So it looks like this. 1 kilogram, 2 kilogram. 2 kilograms not moving. 1 kilogram is moving. Yeah. So it comes along, the trolley comes along, and then they click together, and then they move off together. That's what happens here. Yeah. So I just want you to draw that please. So 1 kilogram, 2 kilogram. You can draw the two of them like this, and then afterwards they're moving like this. So it's 1 and 2 and 3.
Can you go back to the question?
No, I just need you to draw the picture first.
I think 2 kg was more.
Was it?
Yeah.
1 kg. No, 1 kg is moving.
1 kg trolley is rolling to...
Yeah. Stationary means not moving. Stationary means at rest.
The velocity is changed here or the same?
Say again?
Velocity.
Yeah, we don't know what it is. That's what we want to find.
Should be changed.
Oh yes, yes. It won't be 0 and it won't be 3. It'll be something in between. Oh, we definitely less than 3. That's true. And more than 0.
Yeah.
Okay. So, if you look here, what's M1? 1. What's M2? 2. What's U1? 3. And what's U2? 0. So, M1 U1 plus M2 U2, that would be 1 times 3 plus 2 times 0, which would be 3. Yes? And the unit is kilogram meters per second. What's the M1 here? Not really. I'm thinking of this, look guys, I'm thinking of this as only 1 mass now. 1 mass. So the M1
It
is,
will not just stick together.
it will stick together. No, I'm saying they stuck together. They're stuck together now. There's like little hooks on them. Well, it's like this. And now they're stuck together.
But it still sits,
I'm pretty sure I said this in it. When they collide, they stick together. Right, what's the M1? 3. What's the M2? There isn't any. Because there's just one mass.
if I have 0.
Yeah, I'll just write none. V1? V. And V2?
Yeah.
Yeah, there's none. There's only one mass now. So, yeah, it doesn't matter which way you think about it. M1 V1 plus M2 V2, but there isn't any V2 now.
It's 1.
So it'll be 3 times V. So this should equal this. So therefore, 3 should equal 3V. So the V equals 1 meter per second. So this moves away at 1 meter per second, which of course is slower than this and faster than this. Yeah. Yeah. Did you write this down? Yeah, I can go on? Okay. So, a white snooker ball traveling at 2 meters per second strikes a red snooker ball. After the collision, the white ball is nearly at rest and 10% of the kinetic energy is lost. So I'll draw that for you. What you have here is, you have a white ball, which I'll draw as green because I don't have white, so this is the white ball. And it hits a red ball. And its mass is m, and its mass is m. And do I say anything? It's 2 meters per second. This is going at 2 meters per second, and this is going at 0 meters per second. And then they crash. There's a crash. Yeah, this is to illustrate that they crash. And then after the collision, I say the white ball is nearly at rest. And the red ball is moving with some speed, and we don't know what it is.
They don't stick it together?
And they don't, because it's a snooker ball. So they don't stick together, right? If they did, that would be, impressive. Okay, so if I look here, M1U1 plus M2U2, what does that equal? That would be 2 times M plus 0 times M, which would equal 2M. Yep. And then here, M1V1 plus M2V2. Okay, so what's the V1? Zero. Yep. And then here, the M2 is MV. I'll write it in underneath. The U1 equals 2, and the U2 equals 0. And then here, the V1 equals 0, and the V2 equals V, which equals MV. So this here should equal this one here. Yeah, so you get MV equals 2M, so what should V equal? 2. Actually, can I just check something here a second? Oh yeah, sorry, I didn't finish something in that last question. So, if you think about it, that kind of makes sense. If you look here, this ball is the same as this ball. This one is moving at 2, and this one is at rest. If after they crash, this one is at rest, then it's not too surprising that this one moves at 2. Because that's like the same picture except they just swap places. So that's not too surprising. Okay? But then in the second part of the question I say, find the exact speed. So of course it's not really going to be 2. Some of the energy is lost. In the question, let me go backwards. So here, I'm going to call this one now V1 and V2. So now it will be M1 V1 plus M2 V2. That's equal to M V1 plus M V2, which equals M V1 plus V2. So again, this equals this. So now you have M V1 plus V2 equals 2M. So therefore, V1 plus V2 equals 2. But there's a small problem. Now I can't get V1 and V2. Why not? Why can't I know V1 and V2?
We get one known.
I have 2 unknowns, and I only have one equation. So I need to make a second equation, and that comes from here. I say 10% of the kinetic energy is lost. 10% is lost. So if I just go to the side for a moment, here the kinetic energy is a half mv squared plus a half mv squared, which would be 2m. And here the kinetic energy is a half mv1 squared plus a half mv2 squared. But 10% is lost. So that means, therefore, 0.90 times 2m equals a half mv1 squared plus a half mv2 squared. Now why did I say 0.90? What am I doing here? How did I make this? Can anybody see how? How did I make this? Any ideas?
10% is low balance. You have to do 10% of it is of profit. Instead of doing that, just change it to 9%.
Yeah. How much kinetic energy do I have at the start? 2m. But I said 10% is lost. So later I don't have 2m, instead I have 0.92m later. But also I have a formula for how much energy I have later. You see it there? A half mv1 squared plus a half mv2 squared. That should equal that. This is what I have at the start. This multiplies this because I lose 10%. True? And this is what I have at the end, and that should equal that. So this one is a little bit tricky, I know. But what's nice here is the ends cancel. I can multiply by 2, so that will be 4. All the ends, yeah. Because m's in everything, so m goes from everything. It's common. Multiplied by 2, so that's a 4, 3.6 equals v1 squared plus v2 squared. So now you have this formula, which is great because I can put that back over here, and now I have 2 formulas. v1 squared plus v2 squared equals 3.6. Now I have 2 formulas, 2 equations, so could I finish this? Yes. Now because of the time I'm not going to finish it because now this is just a maths problem.
But there's one square, this is one.
Yeah, so we have to use the substitution. You put the second equation. It's like in math class, one linear and one quadratic. Do you remember this?
But they have to root the first, right?
No, the first one you could get V1 equals 2 minus V2, and then put that in. Substitution.
I know, but because that I have to remove the square, right?
No, you don't need to. No, not necessary. You can just get V1 equals 2 minus V2 and substitute it in here. So you can make 2 minus V2 squared plus V2 squared equals 3.6. Sorry, I have to finish something with the last example I forgot to do, and then we're finished, okay? But I want you to, at home later, to get the answer for V1 and V2, okay? I want you to tell me the V1 and V2 tomorrow. Okay, can I go back to the previous example for a moment?
Yes.
I just forgot to finish something here. Have you got this? Not yet? I can go back? Yep. So I forgot, in the last example I also asked you what is the kinetic energy before and after the collision. So we'll do this together quickly. If you take out your calculator, the kinetic energy here is a half v squared plus a half v squared. So what's that? Somebody tell that please. And then here the kinetic energy afterwards is a half v squared. Well, that's going to be 1.5 joules. How much is it here? 4.5 joules, yeah?
Yeah.
So what happened here? How much was lost?
3.
We lost 3 joules of kinetic energy. Thank you. So, what do you call it when you lose kinetic energy? Is that called elastic or inelastic?
Inelastic.
Inelastic. So because 3 joules of energy was lost, we call this collision inelastic. In fact, all the collisions we look at are inelastic.
Really?
Yes, in real life they're all inelastic. Kinetic energy is always lost. Where does this kinetic energy go?
But break.
No, there's no breaks in this one.
Why? It's got...
They're 2 trolleys, they just bash together. Where does the 3 joules go?
Friction.
Yeah, but what type of energy?
Heat.
Listen, I want you to picture it. No.
No, I know.
Picture. One trolley, they come together, they stick, and they move away. I lost 3 joules. Where did it go? Picture what happens. Yeah? Do it again.
Movement.
No. Sound. When they come together,
Sound.
you have 3 joules of sound energy that leaves. Now not only sound, there'll be some heat as well. Heat and sound.
But that means the sound like works a lot of energy.
No, the sound is not much energy. So of the 3 joules, I would say 2 joules are heat and 1 joule is sound. Something like this. Something like this. Yeah, sound is not too much. Alright, so I'll put the questions up on Moodle, but if you want to take a picture, there it is there.
So now when we are speaking, like we use energy?
Correct! True. So as you're speaking, there's energy coming out of you.
Yeah.
And this energy is coming from chemical energy inside of you.
Yeah. So we have to speak less.
Oh, that's not a bad idea.